In this lesson, you will get an introduction to the insertion sort, and we will continue to fill out the worksheet for the metrics for this sort method. If you haven't already done so, go to the video lessons website and choose the Insertion Sort Introduction and Metrics link. Navigate to the related files and assignments. If you haven't already done so, you can access the Sorting Analysis Worksheet PDF here. And as part of this lesson, we will be filling out or working with a document which you can download in Microsoft Word format or as a PDF as we write the pseudocode or practice the pseudocode for the insertion sort. Next, download the Insertion Sort Introduction project and then import that project into Eclipse by going to File and Import, select Existing Projects into Workspace, browse to where you've downloaded the project, and click Finish. In the project folder, you will find our arraytoolkit.lib.jar file, because we'll be using some methods from that, as well as in the default package, the insertion sort class. We are now ready to begin looking at the process or algorithm of the insertion sort. In the Microsoft Word document, we have a list of elements with index numbers and some sample values. That same data is copied down here in the list where we can modify it as we follow through the process of sorting this data. In the insertion sort, you begin by looking at the second element in the list, which has the index value of 1. That's the value that we'll be inserting into the list. So we're inserting element number 1, which has the value 24. So we'll move 24 to our temporary holding area. Next, we copy that value and then begin by comparing it to the value immediately to its left, which is 26. Is 26 greater than 24? If so, then move it to the right and check the next element to the left. Since 26 is greater than 24, we move it here. Now, we would be checking the next element to the left of element 0, which doesn't exist. Therefore, we're done checking, and 24 goes in the available spot. What we have just done is inserted 24 into the list because it's got a value less than 26. Next, we go to the next element, which is element 2. Element 2 has the value 20, which we will now be inserting. So, we'll be comparing all of our other values to 20. Starting with the value immediately to the left, which is 26. Is 26 greater than 20? It is, so that value gets moved to the right 1 spot. Next, we go to the next left position, which has the value 24. Is 24 greater than 20? Yes, of course it is, so we move it to the right. And we've run out of things to compare, so 20 goes into that position. What's the next element that we'll be looking at? 22. So 22 will be the element that we're inserting. So we'll be comparing everything to the value 22. The first value we compare is 26. Is 26 greater than 22? It is, so we move it 1 notch to the right. Is 24 greater than 22? Of course it is, so we move it one notch to the right. And now we are comparing 20. Is 20 greater than 22? If not, then we put the value back and insert the value that we're inserting into the open position. And as you can see, we have a list sorted with the lowest value on the left increasing in values. This time 22 got inserted where it belongs in the list. Okay, let's continue our algorithm. Now we're doing element 4, which has the value 18. So we'll move 18. Oops. We'll move 18 to the position where we store it for inserting, and we're going to be comparing all our other values to 18. At this point, it should be sort of obvious what's going to happen next. 26 gets moved over. I'm going to start skipping a few steps here. 24 gets moved over. 22 gets moved over. 20 gets moved over. And that means that 18 goes in the leftmost box. My next number is going to be 28. So we'll be comparing all of our values to 28. Well, we start with the value immediately to its left. Is 26 greater than 28? It's not, so we put it back. And then we put 28 in the open spot. And as you might surmise, the same thing will happen with 30. One of the advantages to the insertion sort is that as soon as we find a situation where we find any number that isn't greater than the value that we're checking, we can stop looking. We don't have to check all the other values to its left because we know that by now all of those values must be lower than the current value that we're checking. Okay, now it's time to begin converting this into Java code. So we'll switch to Eclipse and begin writing our code. This time, though, we're going to put some thought into how we're going to be gathering our metrics in the latter part of the lesson. What we're going to do is make it easier for us to modify the program by setting up a few constant variables. In Java, a constant has the keywords public and static, also the keyword final, which means that it's a variable whose value cannot be changed. Sort of a contradiction in terms, but there it is. And next we put the variable's type. The first thing that we're going to want to do is create a constant that tells us how many elements we'll be using when we're creating our arrays. And we'll start with 5. In the past, we've begun by declaring an array of integers and then giving it a name and then assigning it using the keyword new. But this time, we're going to create a more useful way to fill this array with values. So we're going to write a method which will be public and static, and this method is going to actually do the job of creating our array for us. So its return type is going to be an integer array. And since its job is to fill an array, that's what we'll call it. Now, we have to decide what parameters our method is going to have. The first parameter is going to be the number of elements that we want our array to have. The second parameter is going to be how we would like those elements ordered. Do we want the elements to start with the first element being the lowest value and going up, or start with the highest value going down, or perhaps be random? So we need to come up with some way to tell our method what we want. And this is another opportunity for us to use a constant. We're going to create another public static final int, which is going to be type our worst case scenario will have a value of 0, followed by another constant, which we'll call type best. That would be elements where they increase in value, with the lowest value being first. And then finally, another static to represent type average, in which we assign random values. Best should have had a value of 1, by the way. And then we'll pass as a parameter an integer which represents the type of fill. Okay, now we're ready to begin writing our method. What's the first thing we need to do is create an integer array. We'll call our array array. And next we will give it our keyword new, and then it's an int array. How many elements will be in this array? Well, that comes from our parameter num elements. Now we're ready to begin filling it. What do we use to fill our method? Well, by now you should know that we use a for loop that iterates across all values in the array. And next comes our assignment to the array. Only in this case, our assignment is going to depend on what type of fill we're doing. So we're going to write an if statement to determine what type we are doing. If the type is equal to type worst, we'll do one thing. If it's not type worst, we'll check to see if it's type best. And if it's not type worst or it's not type best, then it must be type average. So, if it's the type worst, what we're trying to do is fill our array in reverse order. So, we would say array of I equals array dot length minus I. And if it's the best case scenario, then we want our values going in sequential order, and let's start with them having the value 1. So we'll use I plus 1 as our assignment, so that when we're doing array element 0, it actually has the value 1. Okay, we're almost done. All we need to do now is decide how we fill for the average case. In the average case, we're filling the array with random values. And this is where our array toolkit lib will help us out, because we're going to say array of I is equal to array toolkit lib dot random number with a minimum value of 1 and a maximum value equal to the size of the array. Very good. What do we have left to do? Well, we need to, now that we've filled the array, return the results to our program. So we return our newly created array. Now all we need to do in our main method is say that we want our int arr to be equal to fill array. How many elements? Well, we want num elements. And how do we want to fill it? We'll begin by filling it with the worst case set of data. So type worst. Okay, now we have filled our array with data. Our next step is going to be to display that data to the screen. So we'll write a print line labeling this as the before case, and then we'll use our array toolkit to list our values with the label ARR. And now we can run our program and see if it works. As you can see, our before case has array element 0 having 5, then 4, 3, 2, and 1. Let's see now how easy it would be using this more flexible way of programming to change it so that we had 10 elements in our array. I'll simply change num elements to 10, and as you can see, I now have 10 through 1. Let's change it back to 5, and let's this time see what happens if we have a best case array. As you can see, my array is now 1, 2, 3, 4, 5. Let's test our average to make sure that one's working too. So when I run it, I should get randomly selected values, which is exactly what I have. Okay, so we are set to begin writing our actual selection or insertion sort algorithm. Let's put it back to type worst and then begin the process of writing our algorithm. Okay, we're going to switch back to our view here of our pseudocode algorithm, and I'm going to put back my data into its original state so that we can more easily go over and review the algorithm. Okay, so in my pseudocode version, what element did I start with? Well, I started by looking at the value in the element stored at position 1, and we continued all the way up to position 6, which of course represents the end of my array. So how do I write that in Java code? Well, of course it's going to be a for loop, and I'm going to be creating an integer. The question is now, should I just use I as I have in the past, or might this be a good time to choose a very good name? Well, since this is the element that we're inserting, that's what I'm going to call my variable. And what's its initial value going to be? It's going to start out with the value 1 because it's going to be starting with the first, or rather second element in the array, which is located at index number 1. And then I'm going to continue iterating over all the remaining values in R and increment each time. Okay, so far I have done the step of going through the list, starting with the first element, going to the last element. Now what I need to do is take this step where we took this value and essentially copied it into our box over here. How would I represent that in Java? Well, I would say that this is the value that I'm inserting. So I'm going to create a new variable that's going to be an integer, and I'm going to call it the current element, and I'm going to say that current element value, because it's not an index, and I'm going to give it the value of array insert element, because insert element is the number pointing to which element I'm trying to insert into my list. Okay, now what I need to do is begin by comparing each value in my list to this number, which is the value that we're trying to insert. So what would be helpful is we know that we're going to be comparing it to each value to that element's left. So how do I determine which element is to the left of this element? Well, if I'm moving to the left in an array, I'm subtracting 1. So I'm going to say insert, this is going to be the compare index, because it's an index of a variable, and I'm going to say it's the insert elements index minus 1. Okay, so now I'm looking at the element immediately to the left of this value. That would be 26. How do I compare 26 to 24 in Java? In this case, remember that we're actually comparing the value at position 0 with 24. So it's going to be a conditional if statement. I'm going to be comparing ARR of compare to with my current element value. And apparently I've spelled something wrong. Oh, it's compare index. Okay, so this allows me to compare to that element. What do I do if that element actually is larger? Well, if the value in this position is greater than this number, then I'm supposed to take this value and copy it into one position to the right. How do I do that in Java? Well, I can say that ARR of the compare index, how do I access one position to the right of the compare index? I add 1 to the index value, is equal to the ARR of the value that I am actually looking at. So what I'm saying here is that if I am comparing the element at position 0 with 26 and it's larger, then I'm copying 26 one position to the right, which is index 1. Okay, and now I have my next step. What do I do when I have a value that isn't larger? Well, we aren't quite set up to answer that question yet, because in the first step there's no more positions to the left. But if we were on the third element, we would need to keep going to the left in our list. And if we're going to keep going, that means we're creating a loop structure. In this case, it's not a for loop because we don't know our start and end conditions. So we're going to use a while loop. And what we're going to say is, if the compare index goes below 0, we're done searching. So one way to say that is, if compare index or while compare index is greater than or equal to 0, keep going. Now, how do we change compare index? After we've compared a value here, we need to go down 1. So we reduce our compare index by 1, moving the next position that we compare 1 notch to the left. And now we get to the question of, what do we do when we have gotten to the end of our list? So for example, in the first index case, we compared 26 and 24, we moved 26, and we subtracted 1 from the index that we're comparing, which is 0, so our index is now negative 1. But what we want to do is put 24 into this position right here. So, to write that in Java code, we're going to say that our array with the value at compare index plus 1 gets the value of, remember, it's the element that we're inserting, or rather the value of the element we're inserting, which is going to be our current element value. The only other condition that we have to check is what happens. Let's roll our algorithm forward. We got 26 moved over so that we had room for 20 over here, then 24, then 26. So now let's look at the situation where we have the value at element 3. So in that case, we're inserting 22 into our list. So we start by comparing it with 26, and our algorithm already does that. So 26 gets compared, it gets shifted over 1 to the right, then 24 gets shifted over 1 to the right. And our next check, we're comparing 20 with 22. So in our Java code, we are right here. Is 22 greater than 20? And the answer is it's not. At that point, we're supposed to stop checking. So how do we stop our while loop from continuing to process? Well, if it's not greater than, then that's an else condition. And what do we need to do? We need to stop our loop. So we simply break, which will have our code jump to this point in the code, which will insert our value into the proper place in the array. And that completes our insertion sort algorithm. All that's left to do is see our results. So we will print after, and then we will once again list our array values. Let's look at the results and see what we get. 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. Our sort algorithm worked. Okay, so that takes care of the introduction to the insertion sort. What we need to do next is look at the metrics involved in the insertion sort. So just as before, we're going to want to create some integers to keep track of how many compares we perform while doing our algorithm and how many swaps. Now in this case, it's a little bit harder to calculate swaps, but not very hard to calculate compares. Where do we perform a compare in this code? Here's an if statement which compares two values. So that's where we increment compares. The question is, where do we actually perform a swap? One way to think about it is that after we've done this compare, if we had to move a value, that could be thought of as a swap. Oops, it's swaps. Okay. Now, it could be argued that this is also a swap, so let's just put that in for our code as well, for comparison's sake. Now all we need to do is print our results. System.out.println, and we want to print first compares followed by our swaps. Okay, now let's run our algorithm and see what kind of results we get. When we had 5 elements in reverse order, our algorithm had to do 10 compares and 14 swaps to get our list into sorted order. Where this algorithm, the insertion sort, becomes more useful than the selection sort is what happens when the data is already sorted into the best possible order or nearly the best possible order. So let's rerun it with type best, and notice now that only 4 compares and 4 swaps were required to complete this algorithm. That is much more efficient. How about the average case? Well, all we have to do is change one little bit of code, and we can now see our average case is, in this example, 6 compares and 7 swaps. Okay, It's now time for you to fill out the worksheet. How will you go about it? Well, how many elements are you going to be checking first? 10. And what type of data will you be using? The worst case. As you can see, it should be very easy to gather all the data you need to fill out your sheet by simply changing two values and rerunning your program. That concludes this lesson on an introduction to insertion sorting and metrics of the insertion sort.